start the activity, right?
Yes, we
Probably.
didn't start it.
Yeah. Okay. So inshallah, what we'll do now is we'll do the activity first, and as part of the activity, as we try, I think we tried on Thursday as well that you can share, draw, and share the screen. So because all some part of it requires some drawing and modeling. So we'll go question by question. Typically, in a normal classroom, I try to divide us into smaller groups and have a bit of discussion individually between groups. But here it's a bit challenging. So what we'll do is we'll look at the activity, and I'd like you to individually try it yourself. And then maybe one of us can volunteer, or a couple of us can volunteer to share their screens and share the solution, and then we'll have a discussion together as a class. So let's start with this one now. Can you see the screen?
Yes, we can.
Yes, Doctor, I
Okay.
can see.
Okay. Great. Go ahead, please. Try to solve the first question yourself. Use one of the whiteboards built into the Teams, or there are quite a few publicly available ones like awwapp.com, for example, right? And there are so many of them. Just use them to draw the solution and then share with us. So let's take a couple of minutes to do it, and then we'll discuss it. Go ahead, please. Just in the chat, I just put a link to a free drawing tool. Right? Basically, you could just Scrabble there and draw diagrams there as well. So we have a question: can X own many ends? Can X own many shares? And the number of shares? Yes, number of shares could be many. Okay, so anybody would like to volunteer your solution so that we can use it for our discussion?
Yes, me.
Go ahead, please. Share your screen. You can share the screen.
I draw it in paper, so I can draw it in the Teams. If it's okay.
That's okay.
Okay. Wait a minute.
Sure.
Can you see the board
Yes,
now
we
or
can.
what?
We can see.
Okay.
Go ahead,
Let me
please.
start. This is the person class, and this is the company class. And this is the shares.
The shares.
Yeah.
Cool. Now, how many instances of shares we can have?
Multiple, many.
Now, what I meant by that is how many objects I can create for share class.
Share class, you can have many for one
Mm.
person because
Mm-hmm.
every share is one, not many.
Mm-hmm. Mm-hmm. Uh, Anybody else will like to comment on this, because this is a correct drawing, but we like to understand it correctly in a sense that what is the real meaning here. So if you allow me, maybe I can also do a bit of drawing here. So what's really happening here is that we have this person class, right? And this person owns a certain number of shares of a company, right? Now,
Right,
the moment we draw this association class, it tells us what? It tells us that this person, in other words, you can, for a share class, you can only have one object, right? Of course, you can have an attribute which will be what? Number of shares, right? Or total shares, or whatever you like to call it, right? So you will have an attribute here, which will, whose value could be any, like as Abdullah said, right? Like his question was, can they own many shares? Yes, a person can own. So for example, Muhammad can own 100 shares of Saudi Aramco. All right.
right.
But for Muhammad, uh, I don't know why it's stuck here. Okay, so for Muhammad, this, when you're gonna go and write a piece of code for it, you're gonna only create one object of the share class. Okay. And of course, that object's value can be 100 or whatever, 200 and so on and so forth. Is this clear to everyone?
Yes.
Okay. Yes. Go ahead, please.
Yes, Doctor. Why shares cannot be like an attribute for the person?
Ah, it's a good one. Good one. I was waiting for this. Now, this is a scenario where basically, you will say, okay, as a designer, uh, you will come across in a situations where you will say that, I need to fulfill the abstraction principle. And at the same time, I'm interested in, making sure that, these attributes belongs to the classes where they should belong to. So the number of shares definitely are owned by, there is no doubt about it. They are owned by a person, right? But they don't, the number of shares or total share coming to a person actually is not really a person's attribute, because person's attributes are what? His ID probably, his email address, his phone number, so on and so forth. right? And this number of shares as an attribute, or these shares only exist because this person owns a company. The moment he will not own any share of the company, this attribute will not be there, right? Correct?
Yes, if he doesn't own anything, he can still get the 0 shares. Like,
Yeah, 0 shares or null. So this, you may have a situation, if you're gonna put it here, the problem you will face is that you will have, like, if it's a larger system, right? And say, for example, some people own shares, some don't own shares, right? And so on and so forth. And there could be very complicated scenarios and situations where, for example, the chief technology officer is not allowed to own a share, for example, right? This is just a business rule, right? Though he's a person. So in that case, you will have objects with null values in for those, those attributes. All right.
yes.
And from a design perspective, it doesn't really, this is a better solution, right? This is a better solution in a sense that you have a concept here where you're telling and modeling clearly that, these shares exist only because there is an association between person and a company.
So we're gonna make a class just for shares.
Yeah, I mean, this is a simple example. So, just for shares, maybe, right? But usually you have more attributes for these association classes. Like in the example of the airline reservation system, for example, you have a flight going between Dammam and Jeddah with SWE728 every day at the same time, but every flight is a unique flight, right? So you will have scenarios, you will have multiple, but then those flights have so many details, like, number of passengers, and, who was captaining it, and what time it left, and what time it landed, and all of this. So these attributes can be more complicated attributes.
Doctor?
Yes, please, go ahead, please.
And for a person in this design, a person can have shares in many companies, right?
Yes, he can have shares in many companies, but for a company, right?
Yeah, he only has one share object.
Yeah, one share object, yes. Now, Yasser says, what if we're gonna create more objects of one person? Yeah, each one, yes, that's allowed. That's okay. Each person will have one share of a company. All right. And as Ali said, refined class is the way to go. Yeah, we're getting there. So let's go back to the activity. And now let's look at the second question. Okay. I want you guys to just take a moment and, imagine with me that for example, one of your design team member has done this. So we want to understand what exactly you understand from this diagram, both as a designer and then as a coder or as a developer. Take a moment and we'll talk about this. Okay, so guys, what do you think? What's happening here?
Can I answer?
Yes, please. Go ahead, please.
What I understand from these classes, a company can employ many employees, and each individual employee has a period of time which indicates how long he serves the company.
Correct. 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 So a person can be employed at a company, and when he's employed at a company, you know, he has certain employment date range, and this association class is recording that attribute value, right? Spot on. Any questions on this before I ask some interesting
Victor?
observations? Yes, go ahead, please.
For the employment, can I add an attribute, for example, job description, a manager, engineer, etc.?
For the employment, right?
Yes.
Yes. Okay. Now, if this this attribute, for example, it is there because it reflects the relationship, right? Right. This association. Yes. Go ahead and you can do it. Absolutely. So for sure you will have multiple, and maybe if I can, maybe in a couple of minutes I can show you another example. You know, for sure you can have multiple attributes here. Absolutely, Khalid. Yes, please. Yes, go ahead.
What does the dashed line mean?
Okay. Okay. Now this is a notation. Okay. So this is a notation, and this is just a UML notation showing that this employment is an association class. So it's like a special class which only exists because to show the relationship between the person and the company class, right? So these dotted lines or this dash line actually is a notation used in UML to show that this is not a normal class. It's a special class which is called association class.
So is it like a must for a person to have an attribute in employment or something like that?
Okay. Now, or let me paraphrase your question another way. When I should be using association class, right?
Yes.
Exactly, right? So anybody would like to give an answer before we or discuss this? When we should be using association class? Why I should be using association class?
Maybe because if there is a general attribute between the two classes, but you can't put it in one class and the another not, or put it because it's abstraction. So you use this way.
Yes, exactly. Anybody else?
Well, I guess to avoid nullability. I don't want to have nullable or null values in my database or on my code in general.
Yes. One last comment. Anybody else volunteers or want to share his understanding? Yes, go ahead, Ali.
When there is certain attribute that they are the reason behind the relationship between two classes, so you can pull them out and put them in a certain class, so that they reflect the relationship.
Correct. In other words, if I have to really summarize this whole, when we should be using association class, actually you use an association class when you want to show additional information about the relationship. Okay. And this additional information, of course, you know, this association class is like any other classes. It can contain operations, it can have attributes, and it can even have associations with other classes as well, right? But it's a set of attributes and set of operations which exist because of the relationship between person and company in this case. Okay. and they really don't really belong to either one of them to satisfy their abstraction concept, right? Or to fulfill the abstraction concept. They don't really belong to either one of them. They are there because there is a relationship between them, and this is like an additional information you want to store or operate on or do functions on because of this relationship between these two objects. Plus, there is one more thing. This association class can have only one object, right?
Right.
So as a designer, if you want to show that, I want to, then this could be your design principle that, okay, a person can only work for a employee for a company and, only once, for example, right? This could be your rule, for example, right? Someone joins Google and then, he can never come back if he goes away, right? So if this is kind of a business rule you have, then you can go with association class, and this will tell me as a software developer, as a code, as an implementer, that I can only go on and create one object of employment class. Now, how we do it and how we force it, basically, we have design pattern called singleton, and we'll talk about this in coming weeks. Basically, what we really do is a very simple solution from a coding perspective. We say, okay, if I want to create an employment object, what I'm going to do? I'm going to see if there's already an employment object or not. If there is no employment object already created, I'll create a new one. If the next time I try to, or someone else tries to create a new object of employment, and it says, you will go on and first check whether there's an existing object or not. If there is an existing object, you will return that one. Otherwise, you create a new one. Cool. Everybody on board with me on this?
Yes.
Okay. Yes.
Perfect. Now let me share you another example since we're talking about it. So let me share the whiteboard. Now, let's say, for example, I have a student class and I have a course class. All right, so I have a student class and I have a course class, right? And they have a relationship which is one-to-one. One student can only enroll one course, right? Now I have this enrollment information, where it should go. The section number, the grade, the semester.
In a separate class.
In a separate class. Yeah, in a separate class. So that's the first answer we'll have. So we'll have a separate class and we'll call it enrollment. And it can have, all different kind of attributes like section number and maybe semester and so on and so forth. Now, what is this telling me as a designer? This is telling me one per student can enroll only one course. This could be your rule, right?
Yes.
And if you want to, and because he's enrolling it, this section information, this semester information actually, doesn't belong to, though it's there because of a student enrolling a course, but it's not really an attribute of student, correct?
Correct.
Yes.
And then they are not really attributes of course either as well, because this is like, SWE316, right? And this course is offered every semester. So there are certain things which are unique to this course, right? A book, for example, and so on and so forth, and reference material, and does it has a lab or not? But the actual enrollment information, cannot be stored here. It needs to be stored separately.
Can we have more than one association?
Can I have one more association class? Something like this?
Yes.
I never have come across this. I don't think so.
So if we have many attributes that is not related to each other, we should put it in one association or create another association.
Okay. Now, to be honest, in a real scenario, what will happen is that this is more realistic. So you have another class here, right? Sorry, doing this. So probably you will have, come on. So you will have probably, another class here, right? And this student may have a separate kind of association information here. That's quite possible. But for the student within the course, and it's about enrollment, because you cannot have, associations, two types, this got to be one type of an association, right? It's very rare that you will have student will have some other kind of association with course as well. Did I answer this one? Is this clear?
So we'll never have more than one association.
Yeah.
It's rare to happen.
Yeah. I don't think so. Yeah. Because association class will only exist for a specific kind of an association, and usually between classes you only have one kind of association, right? Unless you have multiple, then you, of course, then for each association type you will have its own association class, which is very rare. So what I meant by this is, somehow for some reason we have another type of association here as well, right? Then for this one, probably we may have separate association class. But we cannot have this situation. This is not possible, probably. Is this clear?
Yes, it is.
Perfect. Any questions, guys? Anything else comes to your mind when talking about this one? Okay. Now let's move on to the next question then. What about this case? Same question, or maybe the student class question. We can do that, any one of these two questions. And what I mean by here is, by full class, I mean a required class.
Doctor.
Yes, please go ahead.
We can't see anything.
Oh, sorry. Haha, thanks. Can we see it now?
Yes, thank you.
Okay. So same question, right? Or we can use the one I just drew, the student and the course and enrollment. Any one of these questions you like. Here we are using association class. I'm saying, can we have required class rather than having an association class? Of course you can, but why or when? So take a moment.
I think to create more than one object.
Exactly, to create more than one object. Spot on. Right. So for example, let me go back to the same example, the one we were talking about on the whiteboard. So let's say this is one possible situation. Now, of course, if you want a student to enroll multiple courses, right? Then you cannot have an association class. What's the solution? Go on and try to solve this problem and come up with a solution where you will not have an association class, but rather you will have a refined class. Take a moment and try it.
Doctor?
Yes, go ahead, please.
Can we answer now? Or?
Yeah, share your screen, please.
I didn't draw it. Okay, I will draw it.
Yeah, maybe draw it. Yeah. Share the screen and draw it.
Okay.
Yep. Anybody would like to go ahead and anybody will volunteer to do it, please?
Doctor, I have the solution, but I didn't know how to present it.
How to draw it? Okay. Okay, fair enough.
I can explain it like.
Okay, yeah, go ahead, please explain it. That's fine.
Like a student has he's enrolled in a course, and this course has a lab, so he has to get two enrollment enrollment objects. So the course, it's not two different courses. It's the same course, but the course has a lab, so different enrollment times and sections.
So in other words, basically what we're saying here is that you have a student class, right? And then you have a course class, right? So we have student, and then we have course, and we'll have this enrollment, right? Now, how many students a student can enroll in how many courses? So we want to show that student can enroll in multiple courses. How are we going to do that? So how are we going to do that?
One and a star.
One and a star, right? So basically, you're going to have this relationship somewhere here, right? And you're going to have a relationship like this, right? So star will come where? Somewhere here.
Yes.
Okay.
Yes, and from enrollment to course, it's one-to-one relation.
Right. And in other words, you can even, sorry, not this way. Let me correct this one mistake here. Not this one. Basically, you can even draw it like this as well, right? It will show you. Right. Does it make sense?
Yes.
Okay. So everybody's comfortable with this?
Yeah.
Doctor, do you mind to re-explain what does the diamond mean?
Okay. This is your aggregation, right? Which means, you know, enrollment is there because, you know, if there are no students, then there will be no enrollment.
Okay. Thank you.
You're welcome. So if we go back to our, for example, the same problem we had in the previous one, where we go back and talk about the employment case, for example, right? And we look at the employment case. Yeah, here we go. So you may have a scenario where you, for example, in this case, if your business rule is saying that a person, for example, Muhammad can only work for Aramco once, right? Then this will solve the problem. This will do it. Now, if you want to, for example, say that, no, he can come, he's a contractor, so he can go and join Aramco, and then he can leave and come back and join, and you want to keep track of his history with the company, right? Then, of course, you cannot use association class. You have to go on and use, you know, a separate class like the way we just did it, right? So in other words, the benefit of using association classes is when you want to specifically, you know, model the relationship between them in such a way that, you know, you will have only one instance. So you have one-to-one relationships. But if you have multiple potential, you want to have multiple history kind of a thing, then probably this is association class will not work it, but you need to go on and create a separate, a normal class, which, you know, just to distinguish, we'll call it refined class, but it's just a normal class, but you will make sure your cardinalities are adjusted in such a way that, you know, they reflect the association between the classes.
Doctor, I have a question.
Yeah, go ahead, please.
Can you please go up a little bit?
Yeah.
Yeah. Okay. A little bit more for the diagram. Yeah. Okay. So here, isn't it that if we don't have a person in class, we don't have an employment?
Yes. No, because this is an association class, so this only exists because there is an association. If there is no association, then yes, this will for sure go away.
So isn't it the same as the concept of aggregation?
Correct. And that's why we did it when we had the one-to-many solutions.
Okay. Yeah. Okay.
Got the point? Yeah, absolutely. And that's exactly the same. Spot on. Right. So I think you guys are comfortable now. I believe so, right? Isn't it?
Yes.
Did you find the activity useful?
Totally.
Alhamdulillah.
Yes,
So
yes.
let me
Absolutely, Doctor. Explains more.
Alhamdulillah. Now we'll keep doing it because we're coming into a stage here where we'll talk about these concepts, and we can only learn them by practicing. Now let me ask one more question, which actually, to be honest, I didn't thought of myself, but in the previous section, one student asked me this question, and it was, very, very interesting question. Now, he asked, sorry, I don't want to go to Amazon. He asked the question as follows. He said that if I have a person class, right? You're able to see the screen, right?
Yes.
Yes.
And he said that I have a person class, and then I have the same problem, right? He said, why don't I make an inheritance between person and employment? right? And then I can have an association with company. Will it solve the problem?
We are using the concept of inheritance in the wrong way, I guess.
Exactly. Right. So when you look at SWE, this is the beauty of the design, that you can try to solve the problems in multiple ways, but you cannot go against the fundamental rules, right? So everybody, I believe, is comfortable with this now, right?
Right.
Alhamdulillah. Okay. I don't think I have time to complete it, but probably I'll just show you anyway, because we're slightly out of sync with our other class section, but it's okay. But it's a very easy thing, so maybe I can still use 2-3 minutes to do it. You know this stuff, I need to be honest. So this is the last bit this is the last bit on the design, right? Basics of the design, right? You can see the screen, right?
Yes.
Right.
Yes.
Okay.
Yes.
So basically, we know sequence diagrams and the behavior models, and of course, so in other words, what we're saying here is that you don't have just the static models in UML. You have behavior models, and you have learned them, all of them, in your 215 lab as well. So so far we've been talking and focusing on the structural aspect, and we've been focusing on saying you have the structural, the static diagrams like class diagrams, and we looked at the use case diagrams as well, and we kind of understand that they are useful when it comes to static or structural information of a system. So they give you the static and the structural information of the system. They are great in giving you overview of the application, modeling inheritance in the use case diagrams. You can use actors, so on and so forth. But they don't represent the lifeline of an object, correct? They don't show that. They don't show the behavior. And for you to show the behavior or to show the changes of the objects and how they communicate with each other, you have to use some of the diagrams or the behavioral diagrams. And of course, sequence diagram is one of them. Right? I'm pretty sure you guys are very comfortable with sequence diagrams, correct?
Yes.
Yes.
So basically, they show you a scenario of a use case. So you can have a situation like this, and you have 3 objects, and then you can go on and show the interaction between them, and you can have multiple interactions happening, going back and forth. Sometimes this information is returned back as well, right? Only key point here is that you only show these return statements or messages when it really adds value. Okay, especially at the sequence diagrams can be drawn at multiple levels. At the specification levels, remember when we were talking about the class diagrams, we said that you can have class diagrams and you use class diagrams and for identifying the behaviors, first identify the behaviors. Sequence diagrams are very handy when you want to identify the behaviors. And at this level, you're more interested in the methods and what kind of data is coming back and forth. Of course, in your sequence diagrams, you have these notations as well, right? I'm pretty sure in 215 you guys learned this, right?
Yes.
Yes.
What's the meaning of this one?
That you might add item, then item total, then add for infinity.
Yeah, so it's like a loop, right?
Yes.
Okay, I think it's 10:50 now. I think I'll stop it here, inshallah. I'll use this as, I think we'll have a lecture on Tuesday, right?
Right.
Yeah,
Yes, we
so
will.
let me stop the recording now. I'll take the attendance, and